elimination method, your goal is to either get the same coefficient in front of your x's or the same coefficient in front of your y's, but you want one of them to be positive and one of them to be negative, so that when you add the two equations straight down, one of them would eliminate. A negative 2x and a positive 2x cancel out, right? So we want to get rid of either the x's or the y's. Which one do you guys want to get rid of, x or y? Okay, so if I want to get the same number in front of the x's, what do I need to multiply this top equation by? Okay, and then what would I need to multiply the bottom equation by? Negative 2. One of them is going to have to be negative. If they're both positive, when you add 10x plus 10x, it doesn't eliminate. 10x plus 10x is 20x. Your goal is to eliminate that variable. Biggest mistake I see with elimination is that students only multiply the x's. You can't do that. Foundation 101 algebra, whatever you do to an equation, you have to do to every single term. That keeps your equation balanced. If you pick and choose that you're going to multiply one thing, you've changed the entire equation. So multiply the entire equation by 5, the entire equation by negative 2. A lot of times, this gets more complicated, especially in Algebra 2. You'll have systems of 3 equations, 4 equations. So a smart thing to do is to number your equations so you can follow your work. It's really hard when I'm looking at your paper to see where you went wrong when you've just got a bunch of stuff written all over the place. So I'm going to number this equation number 1 and then go ahead and multiply it through by 5. So my new equation is 10x plus 20y equals, what is that, 360? Is that correct? 5 times 2 is 10, carry my 1, 35, 36. Multiply by negative 2, that gives me negative 10x minus 4y equals negative 216. And then we're going to add straight down. A negative 10 and a positive 10 cancel out. 20 minus 4 is 16y equals 360 minus 216. Borrow from the 6, that gives me 4, 4, and 1. And then divide by 16. So how many times will 16 go into 144? Anybody have a guess? Say it again. 9. 9 times 6 is 54. Carry your 5. 9 times 1 is 9, plus 5 is 14. So it goes in there evenly, which means our y value is 9. Any questions so far? Okay, once we found out y was 9, then you can go back and plug that into either one of your 2 equations. So this was my equation 1, equation 2 after I changed them, but it doesn't matter where you plug it back into. I'll plug it back into the first equation before I changed it. So number 1 here, I had 2 times x plus 4 times now our y value, which is 9, equals 72. Simplify, we have 2x plus, what's 4 times 9? 36 equals 72. Subtract 36, and we get 2x equals 36, and then we divide by 2, and what is x? 18. So x should have been 18, y should have been 9, and that's one way to do substitution method. Questions on substitution method? Okay, again, you could have chose to eliminate the y's instead. I think that would have been easier. What could we have multiplied the second equation by in order to get the same number in front of the y's? Negative 2, so that one's positive and one's negative. Then you wouldn't have had to multiply the top equation by anything, and your numbers would have been smaller. So eliminating the x's would have been easier here. All right, let's talk substitution method. So substitution method, I'm going to rewrite this. Actually, I'm just going to erase this. Any questions before I erase this? Okay. Substitution method, you pick one equation and you solve for either the x or the y, meaning you get x or y by itself. So which equation would you guys want to solve for if we're doing substitution method? 1 or 2? 1. I would say solve number 1 because all of those numbers are even. So when you divide by 2 or divide by 4, there's less chance of having fractions. If you tried to solve for x in number 2 and you have to divide by 5, you're going to end up with 2/5. And unless you just love fractions, You probably don't want to have fractions when you're working those problems. So I'm going to choose number 1. Do you want to solve for x or y? X would be easier because, again, each of these numbers are also divisible by 2, meaning when I try to get x by itself, I'm going to have whole numbers. What would I need to do to start solving for x? Minus 4y. Trying to get x by itself. So I have 2x equals negative 4y plus 72. From here, what would I do? Divide by 2, and remember that you divide every single term by 2. So x is equal to? Very good. Or you may have it written as 36 minus 2y if you chose to put your minus 4y after the 72. I always put my variables first because when we're writing equations of lines, we always want them in y equals mx plus b form, so I just get in that habit. Once you know what x is, then you take that expression and you substitute that into the other equation. Another reason to number your equation. So I can't substitute this back into number 1. It will never work if you do that. You have to substitute it into the second equation. So I have 5 times, instead of x, I'm going to plug all of this in. Negative 2y plus 36. Don't forget that you still have a plus 2y equals 108. And now we're going to solve. So what do I need to do next? Okay, so I need to distribute that 5, right? Which gives me negative 10y plus 5 times 36 is 180. And then we still have this plus 2y equals 108. And notice the whole purpose in substitution is now you only have one variable instead of 2, because the x value we replaced with an expression for y. From here, we combine like terms. What's negative 10y plus 2y? Negative 8y plus 180 equals 108. From here, what are we going to do? Subtract 180. And what is 108 minus 180? Negative 72. And then divide by negative 8. And what do we get for y? Y equals 9, just like a few minutes ago by doing it elimination method. Once you know what y is, I always plug it back in to where we had x equals, just because now that's what we're looking for is x, and it's a little faster. So x is equal to negative 2, plug in your y, 9, plus 36. So we have negative 18 plus 36, which gives us positive 18 for x, which is again what we had a few minutes ago. Questions on substitution or elimination? Because the equation had a positive 2y. Okay, so I just plugged the... No, this gets substituted in for the x in the other equation. So I have 5, and then what x is, which is negative 2y plus 36, plus 2y equals 108. Okay, you're just substituting it in for the variable into the other equation. Other questions? Okay, so you need to think right now, do I feel confident that I can do this on a test, solve a system, no problem? If you don't, make a note that you need to go and do some practice with substitution and elimination. I may throw it back up in bell work again another day, but still really important that you get some practice so you can feel confident. All right, keep your bell work. Let's look at the 2 things that I gave you. I'm going to pause the video for a little bit and let's look at the test. So think back to where we left off with 3-1, which has been over a week probably now, right? We did the lesson 3-1 before we took the chapter 2 test. So 3-1 was all about parallel lines, perpendicular lines, skew lines, and then those special angles, corresponding alternate interior, alternate exterior, same side interior, same side exterior. It is foundational today that you understand what are corresponding angles, what are same side interior, what are alternate interior. You have to know all 5 of those angles. What I need you to understand before we start this lesson is those angles are formed whether the lines are parallel or not. So when I cut 2 lines by a transversal, you have 8 angles that are formed. And you have all 5 of those types of angles in this picture, right? Today's lesson is going to focus on what happens when those 2 lines turn out to be parallel. So instead of them not being parallel, what's going to be the relationship between those angles when those lines are parallel? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to focus on if the lines are parallel today. We're going to learn 5 theorems. 1 of them is a postulate. The other 4 are theorems. We'll start with this first postulate, and then I'm going to show you how to develop the other 4 theorems. So the first postulate is called the corresponding angles postulate. It's a postulate because we're going to accept it as true without proof. And then we're going to prove the other 4 without writing formal proofs. But we're going to prove the other 4. All 5 of these theorems today are going to start with if 2 parallel lines. The whole key to 3-2 is if the lines are parallel. If the lines are parallel. What we're learning today would not be true if the lines are not parallel. So if the lines are parallel, if you have 2 parallel lines cut by a transversal, then the corresponding angles will be congruent. First postulate, corresponding angles postulate says 2 parallel lines cut by a transversal, your corresponding angles are congruent. This is Ashley. It's been in for about 10 minutes. All right, thanks. All right, so everybody with me, corresponding angles are congruent? Somewhere on your notes, maybe on the back, wherever you have a pretty good spot of room, I want you to make a chart because we're going to learn a lot of angles today. I want a place where you can put congruent angles and then a place where you can put supplementary angles. Okay, so maybe on the back of your notes or wherever you have room. Before we go any further, I want you to think about, this has nothing to do with parallel lines cut by a transversal. Can you name 1 pair of angles that we learned back in chapter 1 that are congruent? What is 1 pair of angles that are always congruent? Vertical angles. So I want you to list that under your congruent angles spot. Vertical angles. Okay, vertical angles are always congruent. Then today, we're going to learn some angles that are congruent if the lines are parallel. So I'm going to put a little note there. If lines are parallel, then these next ones will be congruent. And the first one that we learned are congruent is what? If the lines are parallel? Corresponding, and that's this postulate that we just mentioned. So corresponding angles. Bless you. Okay, before we go any further, can you name 1 pair of angles that we learned back in chapter 1 that are always supplementary? Vertical angles are congruent. Linear pair. Okay, linear pair. So linear pairs are always supplementary. Doesn't have anything to do with lines being parallel. Be careful, supplementary means 2 angles that add to equal 100. A straight angle is not supplementary because it is only 1 angle that is 180 degrees. A linear pair would be because it's 2 angles. Okay, today we're going to learn more angles that are supplementary if the lines are parallel. So again, I'm going to put that little phrase here. If lines are parallel before we add any more angles. Okay, so now let's discover which angles would be congruent and which ones would be supplementary based off of this postulate. So right now we know, I'm going to make up an angle. Somebody give me a measure for this angle right here. Any measure for this angle? Okay, let's don't use 90 because 90 won't work. It will skew our answers. 75 degrees, okay? So 75 degrees. Now, using only the things we have listed over there on the board, what do we know that angle 4 has to be? 75 because they're what kind of angles? Vertical, okay? What do we know angle 5 has to be? 75 because they're what kind of angles here? Corresponding. What does angle 8 have to be? 75, because these two angles are vertical, okay? Let's use the other thing on the board. What do we know that angle 2 has to be? Okay, which is what? 105. Because these are what kind of angles side by side here? But more specifically, what kind of angles are they? A linear pair. Okay, what does that make angle 3 then? Because it is what compared to this other angle? Vertical. Okay, what does that make angle 6? Lots of reasons that it could be 105. We've got corresponding, we've got linear pair, so lots of reasons there. What does that make angle 7? And again, because these two angles are vertical. Okay, so now look at the angles we learned that are not listed on the board. For example, we've already talked about corresponding, but we haven't talked about alternate interior. What do you notice about the alternate interior angles? They're exactly the same, right? So that's going to be another one of our theorems today. Let's add it over here under congruent angles. If you have parallel lines, again, only if they're parallel, then alternate interior angles will be congruent. Alternate interior angles will be congruent all the time if the lines are parallel. Okay, look at the picture. What do you notice also about the alternate exterior angles? Does everybody agree? They're the same? So again, this one and this one, they're the same. So again, over here on our chart, if the lines are parallel, the alternate exterior angles will be congruent. Okay, what angles have we not talked about that we learned last class period? Okay, same side interior. So what do you notice about the same side interior angles here and here? They're not congruent. This one's 105 and this one's 75. They're supplementary. Okay, so that means over here under supplementary, if the lines are parallel, then the same side interior angles will be supplementary, not congruent, but they will add to equal 180. What's the last pair of angles we haven't talked about? Same side exterior. What do you notice about the same side exterior angles? They're also supplementary. And again, only if what? The lines are parallel. Okay, so same side exterior angles will be supplementary. Okay, so keep in mind, vertical angles have nothing to do with lines being parallel. Linear pairs have nothing to do with the lines being parallel. Linear pairs are always supplementary. Vertical angles are always congruent. These other 5 angle pairs depend on if the lines are parallel or not. If they're parallel, then these things are true. Okay? And these are the 5 theorems that are in your notes today in this section, and that's really all this section is about. So the first one is a postulate. It's the corresponding angles postulate. We believed it to be true, and we discovered the rest of them. So the rest of them are going to be theorems in your notes. So if you look, I'll come back to this in just a second. So if you look at this, this is really blurry in your notes. It is in the textbook in this section. So if you want a clearer, nicer picture, you may make yourself a note that this is in the textbook. You can look at it there. But the second theorem we have is the alternate interior angles theorem. And again, it just simply says, if the lines are parallel, then the alternate interior angles will be what? Congruent. Okay? Alternate exterior angles theorem. If the lines are parallel, then what's going to be true about the alternate exterior angles? They're congruent. Same side interior angles theorem. If the lines are parallel, the same side interior angles will be supplementary. And just like in section 3.1, this book skips what? Same side exterior. I have no idea why. They rushed to make it. So add up here at the top, same side exterior angles theorem. And it's simply going to restate exactly what the same side interior angles theorem says, except it's about the exterior angles. So I'm just going to draw an arrow to right here and put that it is the same. Okay, so if the lines are parallel and cut by a transversal, then the two pairs of same side exterior angles will be supplementary. Is it okay if we just draw an arrow and say it's the same, but it's for the exterior pair? Okay. Those are your 5 theorems. You're going to have to be able to name them and write them often. So it's just the name of the angles with the word theorem at the end, except for corresponding, and it's the word postulate at the end. So corresponding angles postulate, alternate interior angles theorem, alternate exterior angles theorem, and then the same side interior exterior angles theorem. Okay? So we will be writing proofs, but we will also be doing problems that are not proof related, like this one. So it says find each angle measure. All we're trying to do is find the measure of the angle. So first locate ECF in the picture. So we're looking for this angle right here, right? Very first thing you're going to have to ask yourself is, are the lines what? Parallel. Do they tell us if these lines are parallel? Yes. What is the key that tells us they're parallel? The arrows, not the ones on the ends of the lines, but the extra set of arrows. Remember, that means the lines are parallel. Then I would warn you, if I were you, I would look at it the way we did up here. If you have an angle measure anywhere in your picture, use that measure and go around your picture and find everything. It'll be much faster and easier than doing it a different way. So if this is 70, what else could we say is 70? Okay, it's vertical one. What else? The corresponding ECF. So this could be 70. And now we have our answer. What's the measure of angle ECF? 70 degrees. On your homework, it may ask you to list the theorem or postulate that supports your answer. If it does, what theorem or postulate did we use to get that was 70? Okay, I'm going to add it to every problem we do because on the test, I will be asking you to back up what postulate or theorem you used. So corresponding angles postulate. It's the only one that's a postulate. The other ones are theorems. Yes, ma'am. Like the word? No, you can always use symbols. So if you have a parallel symbol, perpendicular symbol, angle symbol, equal symbol, congruent symbol, if it's a symbol we've learned, you can use it in place of the word. Any questions so far?
Are alternate interior angles the same as alternate exterior angles? So you're right, the theorem.
They are two separate theorems. Alternate interior angle theorem is about the interiors. Alternate exterior angle theorem is about the exteriors. And they're congruent, which we wrote up here. If they're parallel, then they're both congruent. Okay. All right, DCE is what we're trying to find next. So DCE. Again, I would be careful here. I wouldn't start worrying about this algebraic expression. I would use the fact we know this was 70 and now we know this is 70. If this is 70, what does that make DCE? 110. Because, why? What theorem or postulate did we just use to get that this was 110? There's not a supplementary angles theorem. Linear pair theorem. We know that those two angles are a linear pair, and if they're a linear pair, they're supplementary. So this should be 110 degrees. And the reason, if they ask you, would be linear pair theorem. Now, I want to warn you, there's a lot of reasons you could get that answer. You may have looked at it differently. You may have said that these two angles were supplementary because they're same side interior angles and got 110 here, and then said these are vertical, so they're congruent. If you do it that way, then you'll list both theorems. Same side interior angle theorem followed by the vertical angle theorem. Your thought process may not be the same as your neighbor's, but as long as you list the correct reasons, it's totally fine. Does that make sense? Okay. Questions so far? All right, moving on. They did it the long way. We did not need to find X, so there was no reason to set it up like that. All right, find QRS. You guys go ahead, do it with your partner, and then see if you can list the reason that you used as well. What was your postulate or theorem? If you get that one done, then I want you to go on and try to finish the rest of the notes. I'm going to fast forward to the next example and just mark something down here to make sure that you guys understand what this is pointing to. So I'm going to give you a few minutes, and I want you to try to work every example through the rest of the notes. Through 3-3 as well. So I want you to look back, and we're going to start going through these questions and see how you did. So starting with the first one, you were trying to find angle QRS. Again, there are lots of different ways that you could do it, but make sure you found QRS and not the value of X. QRS is this angle right here. And what do we know about the relationship between these two angles? They're supplementary because they're what kind of angles? Same side interior angles. So getting practice for the test, I would have written down same side interior angles theorem. Practice my spelling, making sure that I'm writing it down correctly so that I know how to support my answer. And then that means they should add to be 180. So what is the measure of QRS? 62 degrees. Questions on this one? Okay, moving on to the next one. So on this one, they asked you to find two different angles. EDG is first. EDG. Again, I wouldn't worry about this expression. I would go to the fact that they told me this was 75 degrees. And I would ask myself, what do I know about these two angles? They're very good. They are alternate exterior angles, and therefore they are congruent if the lines are parallel, which they are marked parallel. So then we could just simply say this is 75 degrees, which makes that a lot easier than trying to worry about solving for X. And we can simply say alternate exterior angle theorem. Now, that doesn't mean you're wrong if you worked it the longer way. It's just that's the fastest way, okay? Once you know that this is 75 degrees, now you can use that to find BDG. So now we're looking for BDG. BDG is this angle right here. What do we know about these two angles? They're a linear pair. Doesn't matter whether the lines are parallel or not, those are a linear pair. So that means that those two angles should be what? Linear pairs are always supplementary, which means they add to be 180. So 180 minus 75 gives me what for this answer? 105. And the quicker way to work it would be then to just use that linear pair theorem. Now, again, doesn't mean you're wrong if you did it a different way. It just means you need to explain your thought process. And as long as you got 105 and your thought process works, it's totally fine. So you may have multiple theorems listed here because you thought about it differently. Any questions on this one? Okay, moving on. This one, again, I pointed out because I didn't want you to get confused that these were different angles. So this one went for this angle, this one went for this angle. What kind of angles are those in the picture? Alternate interior. So the theorem I'm going to use is the alternate interior angles theorem. And if the lines are parallel, then the alternate interior angles are what? Congruent. You're asking yourself today, there are only two possibilities. They're either going to be congruent or they're going to be supplementary. And so you're just trying to decide which one is it. Do I set them equal or do I add them and set them equal to 180? And in this case, you're going to set them equal. So 2x plus 10 should equal 3x minus 15. Subtract 2x. You have 10 equals x minus 15. Add 15. X equals 25. Is that our answer? No, because it said find ABD, so you have to plug it in. Watch your directions. ABD is this angle here. So if we plug in 25, 2 times 25 plus 10 gives us what? 60 degrees. Don't forget the little m when you write your answer, and don't forget your degree symbol. Questions on this one? Okay, I didn't see anybody with a final answer before I stopped you on time on the last one, so let's talk through it. Biggest mistake I see on this one is students look at this picture and they say, oh, this angle is pointed to here, and this angle is pointed to here. And what kind of angles are those? They're not a linear pair. They have completely different vertices. So they are not a linear pair because they're not adjacent. This vertex for this one, they're not vertical. Vertical are across from each other when two lines intersect. They are corresponding. But today, corresponding angles are only congruent if what? The lines are parallel. Are lines P and Q marked parallel? No. So you cannot set these equal to each other because even though they are corresponding, they are not congruent because the lines are not marked parallel. So we have to find a different relationship using the lines that are marked parallel. So now I'm going to, one bit of advice when you get to these harder problems on the homework, draw the picture, use a highlighter or a pen or something where you can draw just the lines you're looking at, or look at in the big picture just those lines. So for example, I'm going to focus on this parallel line. Let me use a different color. Let's do this parallel line, and let's do this parallel line, cut by this transversal. So I'm just picking two parallel lines and one of the transversals. Are you guys with me here? Okay, so this is 55 degrees, and we're looking at this angle, which is pointed here. Ignore the black line in the middle. We're not looking at those, so we're just looking at these two parallel lines. It may help you to redraw it.
Yeah, alternate interior.
Okay, so they are on opposite sides of the transversal, so they're alternate interior angles, and because the lines are parallel, does that make them congruent or supplementary?
Makes them
Congruent. So that means one equation you can write down is 5x plus 4y equals 55. However, in Algebra 1, you should have learned that if you have one equation with two variables, there is no way to solve that equation, which is why for Bell Work, we looked at a system that has two equations. If you have two variables, you need two equations. When you get to Algebra 2, if you have three variables, how many equations are you going to need? Three. And if you have four variables, you're going to need four. And you will work problems like that in Algebra 2, where you have a big system of equations and you're solving for multiple variables. And it's all coming back to, can you solve by substitution or elimination? So it's super important that we review it in geometry to help you for Algebra 2. All right, I'm going to go now and look at two different parallel lines up there in the picture. So now I'm looking at the 60-degree angle, which is made by this line. And now I'm going to make it parallel to this one. Oops, come on. And we have this angle that's pointed to right here, and we have 60 degrees. And this then would be the transversal for them. And if you need to, redraw that picture. Blue, blue, blue. This was, where am I at? 60. And this was 5x plus 5y. What do we now notice about those two angles? Corresponding, and if the lines are parallel, they are congruent. So we can say they are marked parallel here and here. So you're looking at only the ones that form the angles you're looking at, and that would be this line, and then the transversal. Okay, so we have 60 equals, or I'm going to write it the other way, 5x plus 5y equals 60. And now we're back to a system of equations we need to solve by substitution or elimination, so we get a little more practice today. Do you want to do substitution or elimination? Elimination would be much faster than substitution because what do you notice about the number in front of the x's? It's already the same. All we need is one of them to be negative. So what would I need to do to make one of them negative? Multiply by a -1. You can't plug in a number for a variable, but you can definitely multiply one of them by a -1. Remember to multiply every single term by -1. So I'm going to rewrite equation number 1 down here. It's going to give me -5x minus 4y equals -55. Notice I'm numbering my equations so I can keep track of what I've done. When you get to those 4 variable systems, if you don't number your equations, you're going to get so lost in your work. Add straight down, the x's cancel. What's 5y minus 4y? Y. What's 60 minus 55? 5. So now we have y equals 5. See how quick that was? And then we can substitute it back into any of our equations. I'm just going to go back up to that number 1. So number 1 equation was 5 times x plus 4 times y, which is now 5, equals 55. What's 4 times 5? 20. And that's going to equal 55. What do we do from there? Subtract 20. So now we have 5x equals what? Careful. 35. Divide by 5, and what is x? 7. So it said to find x and y in the diagram, and we got x equals 7 and y equals 5. Questions? Yeah, depends. Now, these directions, no, because it just said find x and y. When you get to the homework tonight, yes, it is going to say list the postulate or theorem that you used. So to get equation number 1 in green, what did we use? What kind of angles were these again? Alternate interior angle theorem. So you would write down on the homework, alternate interior, sorry, it keeps erasing it, angle theorem. I don't know why it's doing that. That's annoying. Okay, and then for the blue one, what did we do to get the blue one? What kind were these? Corresponding. So then we'll go to corresponding, and what is it? Postulate. Oh my goodness. You got it. I'm not going to rewrite it again. Postulate. I don't know. Okay? That's all you have to write, though, Anna. This is not a formal proof, so you don't have to list like I did substitution or I did subtraction or addition or any of that kind of stuff. Today, it's just listing the postulate or theorem to back up how you started the process. Okay? And then from there, you just solve and get your answer. Unless it says write a justification for each step. If it doesn't say for each step, then it's just for the initial beginning process. Okay? Let's look at 3.3. 3.3 is basically this exact same thing, but the converse. So now we go back to the last test you just took, and remind me, what do converses do to a conditional statement? They switch the hypothesis and the conclusion. So what we had in 3.2 was, if the lines are parallel, corresponding angles are congruent. So 3.3 is going to say what? Exactly. She said if the corresponding angles are congruent, then the lines are parallel. So you're going to have the same 5 postulates and theorems, but they're going to start with converse of. And what they do is they prove the lines are parallel. So we're going to learn 5 ways to prove lines are parallel. You are not going to have that the lines are marked parallel. You're going to be using the converse. If in the picture the corresponding angles are congruent, then that must mean that the lines were parallel, okay? If in the picture the alternate interior angles are congruent, then the lines must be parallel. If the alternate exterior angles are congruent, then the lines must be parallel. If the same side interior angles are supplementary, then the lines must be parallel. And if the same side exterior angles are supplementary, then the lines must be parallel. Do linear pairs prove lines parallel? No. Do vertical angles prove lines parallel? No. Okay? Vertical angles are only made by 2 lines, not 3. And linear pairs are only made by 2 lines, not 3. So you have a linear pair, you have vertical angles, but they don't prove lines parallel. Okay? Only these 5. And it's just the converse of, and then exactly what we talked about. So we'll look at some problems here. Oh, I forgot in 3.2 to go back to something. Would you look at 3.2 notes real quick? I'm going to pull it back up. Super important for the test. So I don't want to forget to talk about this right now. And it was Hold on just a second. Okay, 3, 2, want to do it from here. Okay, so if a transversal is perpendicular to two parallel lines, super important. If the transversal is perpendicular to the parallel lines, what does that mean is going to be formed? If the transversal is perpendicular to these two. Okay, perpendicular means they form a 90-degree angle. So what does that mean when you look at this picture then about all 8 angles? They're all congruent. So on the test I may ask you, how many different measures are formed if the line's perpendicular to two parallel lines? How many different measures are formed? There's only one measure that's formed, right? So there are 0 different, but there is exactly one measure formed. So how many angle measurements are formed if the line is perpendicular? 1. Okay, 1. Now, let's go back to this one. How many different angle measures are formed when two lines are parallel cut by a transversal? 2. Okay, 2 different measures here and only one measure here. Everybody clear? Okay, so I want to make sure that I didn't forget to mention that. Okay, so now go back to the 3-3 notes. Okay, so we already reviewed what a converse does. So now I'm just going to point out these theorems real quick. When you write them, I'm going to be super picky. If you're trying to prove lines parallel, then your answer should start with converse of. If you don't put converse of, then you listed the wrong postulate. It has to start with converse of. Converse of the corresponding angles postulate. So in the picture, if the corresponding angles are marked congruent, you can conclude the lines are parallel by the converse of the corresponding angles postulate. Next one. Again, this is in your book if it's a little blurry on your paper. Notice in the picture, which kind of angles are marked congruent here? Alternate interior. So now we can say the lines are parallel, and the reason is the converse of the alternate interior angles theorem. The only difference is our conclusion is that the lines are parallel, and our hypothesis is that the angles are congruent. So we're just switching it. In this picture, what kind of angles are marked congruent? Alternate exterior. So you can now say the lines are parallel because the alternate exterior angles are congruent. Keep in mind they have to be congruent. If they did this, that says 100, and this says 80, even though it doesn't want to stay. Those are still alternate exterior angles, but are they congruent? No, they're supplementary, and being supplementary does not prove the lines parallel for alternate exterior. Alternate exterior angles have to be congruent for the lines to be parallel. Okay, so that would not prove the lines parallel. Okay, down here in the picture, what kind of angles are 5 and 6? Same side interior, and notice they tell you that they add to be 180. So if they add to be 180, that makes them supplementary, and if they're supplementary, then the lines are parallel. And I remember it as SSS, same side supplementary, same side supplementary. The other ones are congruent. The same sides are supplementary, okay? The ones that start with the words, same side. So this would be the converse of the same side interior angles theorem, and you can say the lines are now parallel. And as usual, what do they leave off? Exactly, so write it down. Converse of the same side exterior angles theorem. And it's going to say the exact same thing just about the exterior ones. Okay, so it's going to say the same. Right, and so we're going to look at a couple of problems then where we're going to use these 5 theorems, and again, it's just these 5 theorems or postulate, if it's corresponding, being applied to problems where you have some proofs, okay? So we're going to start with some really simple ones, starting with this one. It says use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. If it says to show this, we are going to write a 2-column proof. So when it says show, I want you to think proof here. Okay, on the homework as well. So make yourself a 2-column proof. What goes on the left? Statements. Forget it. And on the right, reasons. All right, so then what's the very first thing we always want to try to list if it works? The given, and what are they giving me in this problem? Okay, angle 4 is congruent to angle 8. And the reason? Given. Go to your picture, mark your picture. Do not mark in your textbook. Draw your picture on your paper. 4 is congruent to 8. What kind of angles are 4 and 8? Corresponding. So if 4 and 8 are congruent, then the corresponding angles, if those are congruent, then what should we be able to say?
Parallel.
The lines are parallel. The converse. So now we can simply say that L is parallel to M, which is what they told us to prove. And what's our reason? Okay, and remember, you have to have converse of, or you will not get credit. Converse of corresponding angles postulate. This goes back to if the statement's about lines being parallel, the answer should be converse of. If your statement's about lines being parallel, it's converse of. If your statement's about angles being congruent and it wasn't given, that would be the original postulate, not the converse. Okay, but converse proves lines parallel. Super simple, 2 steps. Any questions here? Okay, let's look at another example. This one's going to be longer. So this one says use the converse of the corresponding angles postulate and the given information to show. So we're going to think proof that L is parallel to M. So once again, 2-column, statements and reasons. Number 1, what are we going to list? All of our given, and all of our given is all of this stuff right here. Measure angle 3, measure angle 7, and x is equal to 30. So I'm going to have measure of angle 3 equals 4x minus 80. Measure of angle 7 equals 3x minus 50. And x is equal to 30. All of that is given. Go over to your picture next and look and see what kind of angles are 3 and 7. They're corresponding. So what do we need to be true about 3 and 7 in order for the lines to be parallel? They need to be congruent, right? So we've got to show that they are congruent, not equal, congruent. So what would be our first step in order to figure out what their measures are to show that they are congruent? Okay, plug in the value of x. And so what is that called when I plug something in? Substitution. Good. So number 2, we're going to use substitution. For some reason, if I write in cursive, it doesn't erase it. So substitution, property of equality. And then we're going to substitute it in. So we'll have measure angle 3 equals 4 times 30 minus 80. And at the same time, we could do the same for angle 7, 3 times 30 minus 50. We just substitute in the 30. Once we substitute it in, what would we need to do to start finding the values of those angles? Simplify. So step number 3, reason number 3 would be simplify. or if you like to use combined like terms. Let's simplify here. What's 4 times 30? 120 minus 80? 40. And you can do that all at once if you want. So measure of angle 3 would be 40 degrees. And then measure of angle 7. What's 3 times 30? Careful. 3 times 30, 90. 90 minus 50, 40. If you wanted to, you could do that in 2 simplify steps, or you can do it all at once. We just simplified that right-hand side. Okay, now that we know they're both equal to 40, what would we need to do in order to start showing that they are congruent? If they both equal 40.
Definition of congruent.
Not yet. We got to do something before we can use that.
Def-
Can't go straight there. There's a step we have to do first. What do we do?
The transversal property of equality.
It's not called transversal.
Transitive.
Transitive. Okay, transitive property of equality. If you have A equals B and C equals B, then A equals C. So we have to use the transitive property first to say measure of angle 3 equals measure of angle 7.
Rowan Turner,
So this would be transitive
Christopher King, Ruby Posada,
property of
O'Brien, Ethan Ornsey.
equality.
Please come to
If they're equal, now what do we know?
come to the office. Also, students, if
Okay,
you are in
now we know they're congruent.
group, you will meet in the, or if you're in the CAF today, you will meet in the cafeteria. Thank you.
Okay, so now we can say they're congruent, and why is the reason again?
The definition of
Okay, to go from equality to congruence, it is always the definition of, I'm going to abbreviate, do not abbreviate on your homework, definition of congruent. Questions? Okay, we did not get all the way through the notes, so here's the deal. I won't take this homework up on Wednesday. It will be due on Friday, but we will finish 3.3 and 3.4 and do constructions. So you do not want to go home on Wednesday with all of this and all of that to do. You should do all of 3.2. You have enough information. We've done all of 3.2. You should also do as much of 3.3 as you can figure out based off what we've learned. But if you're not confident about something on 3.3, just wait. We'll go over those examples in class on Wednesday, okay? There is a picture missing off the core math page 101. So quickly before the bell rings, if you could get out core math page 101, we're going to add a picture to it. Core math page 101, you need to add a picture to be able to do the problem. So if you will get core math page 101 out, or you can just draw the picture on this little slip if you don't have time to get the core math book out. But you may want to put it on there if you do, so you have it when you get home. Core math page 101. Draw the picture exactly like I draw on the board. Should start with 2 parallel lines. So you're going to draw 2 parallel lines. This is number 5, by the way. So on core math page 101, number 5 is a proof, and you need a picture. You may not know how to work this proof anyway yet, since we haven't done the proof examples, but just in case you try to figure it out, you need 2 parallel lines. So draw 2 lines and mark them parallel. Core math page 101, sorry I said 105, 101, number 5. And then in this problem, the first line is P, the second line is Q. It should be cut by a transversal. And the angles that need to be numbered should be this way. So look up here, this should be angle 1. This one should be 2, and this one should be 3. So in order to do that proof, you have to have the picture to know what is angle 1, what's angle 2, what's angle 3. Okay? When's this due? Friday. Do as much as you possibly can. Okay, but not due till Friday.